NanoHub.org.
Online simulation and more for nanotechnology.
Okay, we'll go ahead and get started. So welcome to our fourth webinar in the summer webinar series of using NanoHub for material science and engineering education. So today what we're going to have, so I'm Susan Gentry. If you haven't been here, I'm at the University of California, Davis. And I've been organizing these. Today we're going to have Professor Nancy Ruzycki from the University of Florida talk about how she uses, has students using laboratory data sets in Jupyter notebooks and labs for remote learning. So ways that she's using this to teach her students. So what is NanoHub? So NanoHub is a website that, and an organization that one of the things that it does is it hosts simulation tools. So it's free for everyone to create an account and use the tools. And so researchers, what they do is they share their simulation tools that they've used or they've created, they share these on NanoHub. They're for anyone to use, whether they're researchers or students. And the simulations run remotely and are visualized remotely on computing resources in, I think it's in San Diego. And so only a web browser is needed to do these free simulations. Your students don't need to download software to run simulations. Then the other thing that is useful for it as an educator is that it also can be used as a repository for teaching resources. If you look on NanoHub or if you want to share these yourself, some of these include demonstration videos of how to use tools or explanations on topics like machine learning. There's also simulation projects that people are using in their classes and other types of course activities. And so one of the benefits as an instructor is if you decide to share any of your tools or any of these teaching resources is you get a fixed web address with the DOI and metrics on the unique numbers of viewers. And so this can be useful when you're trying to justify the work that you've done, or if you have a grant, or if you're up for promotion, to be able to show the impact of these educational resources that you're developing. And so the last thing I want to share before we get started is I encourage you to join other educators on NanoHub. We have two groups, so you can join, once you have a NanoHub account, you can join groups. There's two that are related to material science education. The first one talks generally about MSE tools that you might want to use in your classes on topics like ab initio methods or diffusion. So this is the materials groups/materials. The second one is an instructor-only sharing page. So this was created in March in response to the COVID-19 pandemic. And so it's just where people are sharing tips and tricks and how they can, multiple choice questions if you need, or lab demonstration videos, things like that. So you do have to be affiliated as an instructor with a university to get access to this one. And so the link is there, and I'll send that out later as well. Okay, so what we're going to do now is our main presenter for today is going to be, as I mentioned, it's going to be Nancy Ruzycki. So I'll let her take over and share with you how she uses these tools in her classes.
So I'd like to welcome everybody today, and I have less of a presentation than I do having a walkthrough with you on how you can use NanoHub within your classroom. And I'm actually going to take you into building a Jupyter notebook for your class. So if you have NanoHub up, that would be great. If you have Jupyter or Anaconda installed on your home computer, that would be great. So I am actually going to demo this for you. This is being recorded. So if you want to watch now and try to develop something later, that would be good. But we heard that you guys would like to have a little bit more hands-on. And so we're trying to do a little bit more hands-on practice with you. So I'm going to take you to what I see when I log into NanoHub. And so I'm logged in, and the first thing that I'm going to do is go to my dashboard. And NanoHub is a wonderful portal, but it is so very large that sometimes it's difficult to navigate. But I try to keep everything I want to use on my dashboard, and that's helpful. So what I'm going to see is I'm going to see some of my favorite files that I have, and I'm going to click on the link to get to Jupyter Notebooks. And when I do that, this is going to come up. So it looks like, okay, so I'm going to show you where it is. This is my screen, and these are the tools I use the most. And when you have a tool you use the most, you can add it to your dashboard as your front page. And that is the way to go, because you will always know where your Jupyter Notebook is. And so if you can, go ahead and get your Jupyter Notebook up and running. And when I go to my page and I look down here, it will show me what I have open. And you want to know what you have open, because sometimes if you leave things open in NanoHub, it will take up the space that you're allocated, and you won't actually be able to use things. You'll actually have to close or terminate some of your sessions to get enough space to work. And this is the complaint I hear the most from my students when they're using it, is they forget they may have a lot of tools running in the background. So once you go to the tool, now if you don't have that tool, you can go to all tools and you can actually search for the tool. So here's a whole bunch of tools, and I can actually search in here for the Jupyter, right, notebook. So when I do that, it'll pop right up, and I can click the heart and I can favorite that. Okay. Does anybody have any questions on how you can get into the Jupyter Notebook through NanoHub? Okay, so once I'm in that notebook, this is what I'm going to see. And so if you've never opened a Jupyter Notebook before, you're going to have to think about what's going on. And so the way the Jupyter Notebook works is that it has files associated with it, and in NanoHub you can actually create folders, and Tanya loves folders. And so folders are a good way to work with your data. But I can create a new folder, or I can pull things from a folder I use. And so the first thing I might do is upload data that I might want to work with. So when I click on my data folder, I can open that up, and I can click in whatever data I might have brought in. Okay? And so this is where, as an instructor, I might actually bring in data. So I brought in a set of DSC data that I'm going to show you how to work with, but you can bring in data yourself. So if I want to bring in data, I'm going to go and I'm going to upload, and it's going to take me to my documents, and I have sets of data here for DSC data, and I can pull in one. Now I'm going to show you in a minute that you may have to treat your data before you bring it in, but these are all examples. If you can see to the side, these are examples of differential scanning calorimetry data that we have from the student laboratory. So then I can open that file, and then I can hit upload, and it will upload that file. So now I click, it's shown up in my file. It's an XLSX file. You can upload CSV files. You can upload ASCII files. So then you just hit upload. Now I've already uploaded it, so I'm just going to go ahead and overwrite it. Okay. So now I can bring in different kinds of files when I'm in there. Okay, so this is the first thing you need to do if you plan on doing some kind of assignment for your students where you want to use data. You're going to need to bring into that data. Now, you can also, if you don't want to use NanoHub as your base, you can actually go to your computer and you can download your own version of Anaconda, and you can run files from Anaconda. Now I'm going to show you, now I've switched out of NanoHub to my own computer. So why might you want to use NanoHub, and why might you want to use your own computer to do work? And so NanoHub is really nice because everything lives in the cloud, and it doesn't matter which computer I'm on, I can access those files. The other advantage of NanoHub is that they have every single library you could possibly want to use in Python already loaded into NanoHub. And so if you are not someone who's really comfortable using programming and adding libraries and doing those sorts of things, then NanoHub is a good alternative for you. The other reason I think NanoHub is really nice for courses is that I can set up a course within NanoHub for my students. I can put the Jupyter Notebook in there. I can put sets of data in there. And all my students have to do is log into NanoHub, and they can do the work through NanoHub without having to go through the university browser or whatever Canvas or whatever learning management system you have pulled up. The thing I don't like about NanoHub, the only thing I don't like about NanoHub is that I live in the country and I have sometimes very slow internet, especially when my mother, who I take care of, is streaming movies on Netflix. And so NanoHub can be a little laggy. And when it is, then I just switch over to my computer where I have my own version of Anaconda and I can run my own experiments. Now, I'm in a Jupyter Lab notebook, and the only difference between what you see in Jupyter Lab and in Jupyter Notebooks is just the way you access data. And so in the Jupyter Lab, you have files on the sides that are tabs, and those tabs and files, I can open and close different windows, and I can see at a glance what all my Python notebooks are that I have loaded on this particular computer, and I can pick them easily. When I'm in my Python notebook, I see my files like this, and then my notebooks will open in a separate window. And so there are benefits to both kinds of programs, but basically when people talk about Jupyter Labs and Jupyter Notebooks, it's interchangeable. There's really, as far as I can tell, there's no discernible difference. So let me first show you some examples. Does anybody have any questions on just sort of those nuts and bolts? We haven't started to build out a program yet, and we will, but these are sort of basic notebooks. Workshops on Anaconda. So Anaconda, you don't really need a workshop on. So Anaconda, so I'm going to open it. So Anaconda Navigator is just a software program. It's a package. And that package downloads and installs. Yeah, Anaconda's not up yet, so it's got to load up. I am sharing the browser, and Anaconda is going to pop up in just a second.
Okay.
So Anaconda is just a package that you can download, and as soon as it opens up, I'll show it, because when Jupyter runs on your computer, it runs through a browser. It creates a local host. Anaconda is just the program that runs it. So now I'm going to share my window and show you what Anaconda Navigator looks like. And these are all really good questions because it's not always intuitive what you should use. So Anaconda is free, and Anaconda, when it downloads, it will download a bunch of programs with it. And Jupyter Lab and Jupyter Notebooks are two of the programs that you can actually that come with the package. You also get R, which is very nice because R is also a very powerful program that you can use. And then you also get Orange, and that's a data mining framework, and Spider, which is also like a Python development thing. And so you can have all these different packages that you get for free. And so there's really, Anaconda is just the package that you would download to your computer. And if you type in Anaconda Navigator, it's freeware. They have very explicit directions for downloading on Mac or Windows or Linux. And so you just have to go there and find that. And it's pretty simple to get those pieces. So let's go back to my browser Windows. And so when you launch Anaconda, it operates through localhost through your browser. And so it's going to pop up just like this. And once it pops up, I can open programs. And so I'm going to share with you some examples of programs that I've written for my students in some of the classes I teach. So I taught statistics, engineering, and so one of the things I teach when I teach statistics is Bayesian probability. And so what I did when I designed my statistics class, it was called Error Analysis and Experimental Design Optimization. And so when we went into experimental design optimization, I taught them Minitab because that's what engineers like to use. I could have taught them R. R is equally powerful, but within our department, we liked Minitab. And I do a lot of programming in Python, but our university likes Matlab. So I actually wrote programs in both Matlab and Python that did the exact same thing, so my students could use whichever language they wanted to. And so here's an example of a simple Bayesian probability. And while it looks like a worksheet or a PDF, this is actually all written in the Python code. So Python has a way for you to do markup language, and it's like a LaTeX editor, if you're familiar with LaTeX. And so you can just type in, and I didn't even use the beautiful math language editor that you can bring in. I just sort of typed it out. And then when you come down here, I gave the students the homework, which was around a diagnostic test. So the question was, the diagnostic test has a 98% probability of giving a positive result if you have this disease called Thrift-Shaw's, and a 10% of giving a false positive when you are a non-sufferer, it will return a false result. Now, it's estimated that 0.5% of the population are sufferers. So now we don't know whether the person has the disease or not. And I want the students to calculate the probability that the test will positively, correctly diagnose a sufferer, and then correctly identify a non-sufferer, okay? And so that's a Bayesian problem. And so all I did was set up the variables and give them the values that I needed. And then I created the equation here. That's the equation for the Bayesian probability. And then I asked it to print out the probability of a positive test. And then I had it print the probability that the test misclassifies the illness. And then the students just run the data. And so this is super simple. And so then I would give the students a problem where they have to change the variables, or they have to go through. So Tanya wants me to zoom in a little more on my computer. Tanya, is that a little better? Yeah, it's good because I can't see what you guys see. And so it's always nice when you have that feedback. And so here, all I did was just type in the math, and then I would give the students another problem that they would then themselves have to solve based on the problem I gave you. Okay, so Tanya wants me to zoom in one more time. Is that good, Tanya? Okay. All right, so that's an example of a simple one. Another one that's very common that we teach in statistics is the Monty Hall problem, right? So the Monty Hall problem is the common problem where you have 3 doors, and 2 of the doors have goats and 1 of the doors has a car. And then we want to know, if we know one of the solutions, how does that change the probability, and whether I should select a new door or stick with the door that I originally picked, because I now have new information. And so here's the coding. At this time, I need to import some fancier packages. So you're importing a package called NumPy. I want to be able to do some randomness, so I import random. You do that, and this is what's so beautiful about these packages. These packages themselves have all the embedded coding, so you're not having to do a lot of coding. You just have to know which package you need to pick to do the job that you want. So here I've named my doors A, B, and C. These are variables. And then I create a list of my doors, and then the prize will be behind a random door. And then I select, I want people to pick a door, so I ask them to do an input function. This is going to ask you to make a choice of door A, B, or C. And then I have an if-else statement. So if you pick the right door, oh, you get a prize, but if not, it's going to kick open the next point, where is you get to select whether you're going to keep the door, get rid of the door. And then once you keep the door, get rid of the door, then you have other choices. So this is just basic programming. It's nothing really heavy. And then here's what you get if you win the prize, okay? And so here I have some text. And then we have whether you want to pick the door and whether or not you pick the right door. So I would give the students this problem to run and understand in Python. And then I would give them a problem where we're now going to change the probability of the doors, and then they would have to rewrite the program to reflect it. And so these are all examples that I've used with students. And again, they're all basically simple. So here's one that's I was going to show you. I have it both in NanoHub and on here. And this is to figure out if your data is normal or not. And this is important, especially for students in engineering, where we have examples of data and we don't know whether our data falls into a normal data set, and then we apply our Gaussian statistics, whether our data is a Poisson data distribution, and then we have to apply Poisson statistics. And so this little program was a program that I wrote to have students look at the differences in data and then be able to check it against a normal distribution. So for this one, I needed NumPy. NumPy allows you to manipulate numbers. And I want to plot, so I use a Matplot library, so I import that. And Pandas allows me to make tables, although I actually didn't include the tables in the version I'm showing you. I'm trying to keep it super simple. And so I actually created 2 random variables where I could generate fake data. So I made a data set that's normal and a data set that's Poisson. And then I sorted the data in ascending order. And then I went ahead and made plots of that data. So here I'm plotting my normal data, and my normal data should show a normal distribution across my bins. And then I plotted my Poisson data, and my Poisson data should look discretized because it's Poisson data. And so I have this discretized data. And then I'm going to take the data and I'm going to create histograms for it. And then I'm going to put a vertical line at the mean, and then I'm going to put dashed lines at 1 standard deviation away. And when you look at the code, there's almost no code to it. And then I plot that data in a histogram, and you can see indeed that you have a normal distribution. Okay, so now when I plot my Poisson data at the same thing, you can see my Poisson data is clearly not normalized data. And so what I would do in my class is I would have the students run this program, talk about the differences in the data, and then I would give them a new data set. So I would give them like a hardness data set, and they're measuring the hardness of the same material over and over again. And then they run that data and they tell me whether it's a normal data set or not a normal data set. And then I give them a data set that's a Poisson data. It might be a counting experiment where they're counting, say, like radiation counts or lights, like in a photodetector. And then they're going to run that data, and they're not going to be able to see that data as normal data. Okay. All right. So that's an example of some statistical data sets that you can do. And so we have a Bayesian, I have a Python statistics one. This is one that I use. So at the beginning, so that's what I did when I taught statistics. And I also teach laboratories for students. I teach the junior material science laboratories, and I teach some of the senior laboratories. And so what I did was I created a simple tutorial for students in the labs to get started. And some of them remembered, yes, you can download your notebooks once you put them up in NanoHub, Dr. Rivas. So when I do my lab, one of the first things they do the first week is they'll work through simple statistics again. Now they've already done some Python notebooks with me in their sophomore year in both lab and in analysis class. But when we get into the junior lab, they're expected to do it pretty much right off the bat. So here's the tutorial I gave them. The link for the tutorial is SciPy. And SciPy has a series of lectures, and I'll put that into the chat. They have excellent resources. There are so many resources out there. I think part of the problem is figuring out which resources are the most useful. And so I took the resources they had and I rewrote them into a notebook. And so we have Anaconda, students can download it, they can run through our UF apps, and they can run through NanoHub. And so here, the first step you're always going to do in Python is decide what libraries you need. So we generally need data tables, so that's going to be the pandas library. You need NumPy, which are the math ones. SciPy is your stats one, and we use Matplotlib for plotting. Now, there are much fancier ones that you can use depending on your expertise. I think these are probably the basic 4 that most professors can use with their students pretty easily. And so when we import our libraries, we import them by name, and then they have these little abbreviations. And the abbreviations you have are what you use when you type your code. So I'm going to import pandas, my data table, as PD. And so whenever I'm going to call a data table, it's going to have like a little PD piece with it. NumPy will be NP, Matplotlib will be plot, and SciPy will be stats. Okay, so here I go through and I explain to them how we set up a data frame. And we're actually going to make a random generator, like I love random data. So we're going to create a random generator to create some data frames. So I'm going to make something I call data, which will be my data, and I say pd.dataframe, and I'm going to build a data frame that has data in it. So I want gender, male and female, and I'm going to generate some fake data for height and some fake data for weight. And my fake data for either your male or your female, you don't get a choice for that one. But for your height, I said, well, let's take it between 69 and 100, and we'll have some intervals here. And so I set up my data, and then it gives me a data table. And I wanted a bunch of data, so I did 200 rows, right? And it always starts with 0. So it goes from 0 to 199, and it tells me all my data. Now, if I don't want to show all my data, I just want to make sure I have some data, I can use a statement like data.head, and it'll just give me my headers and some of my data, the first 5 lines. And that's useful for students because, you know, they like to print out stuff, and then they've got like hundreds of rows you have to look at. But I don't need to see 100 rows. I just need to have some rows. And then in Python, the statistics becomes much simpler. So if I want to know the mean, my data table is called data. The column that I'm calling is called height. And I want to know what is the mean of that column, and it will give it to me. And I do the same thing, right? If I want to know what my standard deviation is, I can type in STD, and it will give me my standard deviation. Okay, so now I can also call all of my data. So if I want to describe all of my data, I can say data.describe, and it gives me the general statistics for all my data. And then if I want to plot my data, since I'm looking at height and weight, I probably want my students to use a box plot. So I'm going to show them how to use a box plot. And again, when students start out, I think it's totally fine for them to copy and paste your code, but then try to play with it. All right, so now I have my data plotted. So I say plot the data in the table, it's box plot, and then these are just some figure layout pieces, and I want a title on it, height and weight, and then I want to save it. So it will actually save that to a file on my computer once I run the program, and it will call it heightweight.png.
Hey, Nancy, can you scroll down? I don't see the part that you're with the box plot.
Okay, so
I see the loading Python libraries, like setting up your table.
Okay, so what I'm going to do is I'm going to log back out and log back in. Okay?
Okay.
So Tanya, do you want to demo? Do you want to show them Joseph's
Yeah, I was thinking I could share the screen with engineering.
As an example?
Yeah, and then
yeah. Okay, and then I'm going to leave the meeting and come back in. Okay?
Okay. All right, let's try that. Okay, and in the chat box, we shared that link, which is nanohub.org/tools/engineering data. So that will take you to this page in NanoHub. You need to be logged in, and then we click on launch the tool. It'll open up this this notebook. And this is one that this notebook, it'll just take a few seconds to launch for each of you if you're trying to follow along, but it is linked to several other notebooks. And so you would click on the first one to see the set of notebooks, the first set of notebooks, which has a whole bunch of different topics. And then there are 2 other notebooks for the hardness lab and LED lab. So the way that these published notebooks work is that you find the top of the page and click the run button to run through the cells. There are 2 types of cells, the code cells and the markdown cells, and you can run both of them. You don't have to skip the markdown cells. And in this particular example, it's just using the pandas library because it'll be working with data frames. And what's nice about the published notebook is that the Excel file is already in NanoHub. So when you launch this tool, the data is already available. And so when I click on run, while the cell is running, there's an asterisk in the square brackets. And after the cell is finished running, you'll see a number. And then here you can see all of the data. And this is one format for viewing the data. And you can see that there are, several chunks of data. And actually this one goes on and on and on and on and on and on. Okay, so as we continue through the notebook, they're going to show you how to do different tasks with the data. So this next set here shows how to look at just part of the data. So here,
So what we were doing here is trying to pull out data. So we pulled a huge data set for heat treatment of metals from a Kaggle website where they have very large data sets, but we really don't want everything. We wanted some specific data related to the hardness of material for one particular heat treatment. This one had about 8 different heat treatments. So when we went down, the next thing Joseph did, go ahead down to the next section. The next thing Joseph did was just pull a subset of that data. And then he wanted to rename and delete columns based on what we really wanted. So this had soaking time, like a pre-soaking time for preheat treatment. and then it went into a more advanced heat treatment. And so this, the purpose of this notebook was to show you that when you pull down data sets, your data set is not going to be ready for your students to work with, and you're going to either have to train your students to clean up their data sets before they do an analysis, or you yourself are going to have to clean up that data set for them. So as you go down, this notebook basically walks you through. So we picked certain temperatures and compositions of the alloy that we wanted, and this will take you through how to change the name. And I think we got a typo in there. It should say printing names of columns. And then we go down, keep going down. Yep, and Tanya will change it right now. Looks beautiful. And then we go down and we can pull data from specific columns. And now when you look at this one, it's much cleaner. We only have the hardnesses that we actually want from the data set. And then we may want to join data together. So this notebook is a little more advanced than what I was showing you in my simple notebook, because now he's going to show you how we can take data from 3 different spreadsheets. Maybe you've got a run 1, a run 2, and a run 3, and you want to concatenate that data, which means to pull the data all into one view. And so he shows you here how to do that. So we can concatenate the data so that we could take 3 data sets and turn it into one data set. So that's what he's done here. Tanya, if you scroll down. And so again, this data, the intent of this sheet is to just show students how to work with the data set. And here he does transposing data frames. He's showing them how to transpose it so that I can now, instead of having column titles, I now have rows. And so now I can look at the time in minutes versus the hardness. So all you're doing is viewing the data a little bit differently. And so what we tried to do is create a series of short data sets so that we could show people how to do some specific kinds of data analysis that you might see or you might want your students to do in a laboratory. So Tanya, can I try to share my screen again in case it actually works? Yep. Okay. And so this is an example of a typical data set from a DSC. So if you've ever run differential scanning calorimeter or you've run real data, you know you're going to get a lot of headers. And those headers present a problem to your data set when you go to bring it in to use in Python. And so you have to understand what your data sets look like and how you're going to have your students work with that data set. And that's one of the reasons Joseph made that program, was to show you how to work with data sets. And so I have 43 rows of headers. But now when this data gets pulled in from the ASCII file to the spreadsheet, there's discontinuity in the data. And so I should have a column for temperature, time, the differential scanning, so that's going to be the heat signal where the heaters are turning on and off as the material goes in. This is the sensitivity of the machine, and this is the segment for the heating. So I ramp up the sample, I ramp it down, I ramp it up, I ramp it down, traditional differential scanning calorimetry. So I should have about 6 different segments or 7 segments. But if I scroll through the data, you can see that the machine has an issue with the way it's displaying data. And that means that if I go to do data analysis on it, and I hope this is displaying, you can see that there's a column shift. Why? I don't know. That has to do with the way the instrument is writing the data to the file. And so I'm going to have to clean that data up, or I'm going to have my students clean that data up before they actually use it. And so what I do is either I have the students bring the data sets into Excel first and look at them And then they can clean up their data by just cutting the data out and then reorganizing their columns. And so here I've just truncated segment 1, and then I would create a new tab for 2, 3, segment 2, 3, 4, 5, and 6. And I actually have 10. This looks like this run had 10 of them. And then in the spreadsheet, you could concatenate all that data if you wanted to, or you could treat each file individually. And these are some of the things that I don't think people talk about when they talk about, hey, let's use Jupyter Notebooks or Python. We have to understand, and we have to help our students understand, what do the data files look like coming in? And it's the same thing. If you're going to use tensile testing data, there's going to be a lot of headers on the data. And those headers have to be removed before you bring it in to your program, or it could adversely affect what you're seeing in your program. Okay, now I'm actually going to try to share my data files again, and we'll see if they show up. Okay, so now what I've done is I uploaded that file, and that file is over here in my file folder. And if I look, I'll show you how to do the exact same thing in the Jupyter Notebook. So I have that file in, and now I'm going to import my statistics, and this is like an extra line I didn't need. And I'm actually going to read in the data file, and it's just really a simple thing. I have pandas, read my Excel file, and here's the name of my file. And now I want to display that file, and here's all my data from what I cleaned up. And now I want to plot that differential scanning calorimetry data. So I just have my students say, all right, let's name and create a variable we call X and a variable we call Y. And I don't need the time, and I don't need my sensitivity, and I don't need my segment number. I really just need my temperature and my signal. And so I call that. So run 1 is the name of the data table, and I'm pulling temperature. And then I'm going to do the same thing for my Y data. And now I'm just going to plot my DSC data. And if you look at that, that's a nice DSC run. I see my TG somewhere around 60, maybe 65. I have my softening and melting occurring somewhere around 175. And then I could apply more statistics to it, but this is really just a simple example of how we can actually plot data. And so you can take data and you can have students start to learn how to plot data. And this is just a simple program about how to pull that data in. It doesn't matter whether that data is DSC data or it's tensile data. I just now have this nice plot of the data that I can further analyze. And I think this is where instructors can start pretty easily with data in Python, is to give them these simple experiments. Okay, I'm going to show you a little more complex experiment, and then we'll open it up for questions because we lost a little bit of time. And again, all these notebooks are available. So this is an LED cutoff voltage experiment that students do in our laboratory. So we have power supplies. They're going to measure the cutoff voltage in the LED and use that to back out the wavelength. And so it's a classic experiment in physics. We actually put a material science spin on it. You can see that we wrote the directions to the lab. It looks like a beautiful sort of directions piece. Joseph used the equation editor to get lovely equations. And then when we go into the experiment, we can pull in our data sets, and this will pull it in for every single color LED we used. He shows them how to calculate the current based on the technique we used, and then he's going to plot the data. And here we've actually created a fitting function in the data. So I'm going to skip down to the data to show you the fitting function within the data. And you can actually fit lines. There we go. And so not only will it plot beautiful plots for your data, but it actually creates a fitting function that lets you find the cutoff voltage in your LED, and then it will take that cutoff voltage and put it into a table and then calculate the wavelength and compare it to the published wavelength for the LED. Now, this is what I would like my students to be able to do as a laboratory report. And so I might show them how to do one of these or a simple version, and then they're going to have to create this more complicated program to be able to do it. And so what I tried to show you today is just some simple examples of how you can actually pull the data out. And if I go to my NanoHub notebook, I do the exact same thing in my NanoHub notebook that I just did with you before. So here's the exact same lab that I showed you before with the deviation from central tendency that I just ran in NanoHub notebook, and I can save that experiment. So let me slide this over. I can save that experiment, and then if I go back to my notebook, if I want to download that experiment, all I have to do is click on it, and I can download it, and I can download it to my own computer from NanoHub. And so it doesn't matter whether you're running this on your own computer or you're running it on NanoHub, they all work exactly the same way. So all of these programs run exactly the same in both NanoHub and if you have Anaconda on your desktop. So with that, I'm going to stop sharing, and I'm going to open up the floor for questions. And again, we have a lot of these materials available for you. If you'd like to have materials available, we also have tools on NanoHub that you can just use the tools. Okay?
Nancy, do you want to answer the question in the chat? Do you see that?
Yep, I sure do. So we show them how to use Python and NanoHub to visualize the data, and then we do ask them to do something more sophisticated, yes. So we basically provide them with a shell program that gets them started with data, and then they're expected, once they start to build fluency, every time we do an experiment, we add a more complex thing that they're going to do in Python, and then by the end of the semester, they're writing their own Python code to do different things. So we sort of give them the basics, box plots, fitting, statistics, and then they themselves have to decide which one they use and then what analysis. And they really, I will tell you that they will go pretty far on their own because it's simple enough and there's enough documentation out there that they'll be like, oh, I graduated from Matplotlib and I'm using fancier plotting tools now. And you're like, great, great. So absolutely, start them simple and then move out from there. Any other questions? Because I think that we have a lot of data sets, and if we're doing remote learning with students, this is a great chance for you to just pull, if you can't do tensile testing in person, you can actually pull old tensile data off your equipment and then give them a shell notebook and maybe show them how to do some fitting on, say, a brittle material like titanium, and then give them some interesting alloys that they're going to have to analyze on their own, and then figure out, like, say, the area under the curve to find the toughness of the material. So there's a lot of interesting. So I have classes that range anywhere from 60 students to 100 students.
And so do they do this, since no one else is asking all this question, do they do this in multiple classes then with you?
Yes, they do. And
classes,
yeah,
at least.
And we're trying to build it across the department. And this is the thing, right? So it can't be one person, and it's sort of been one person for a long time that's been teaching them programming and context. But when they take programming at our university, I don't know about your university, they basically learn, say, Matlab, and they make a game out of it. And that's great, right? So they're learning a lot about loops and a lot of the calling and variables, but an engineer is not going to build games. And so how do we have them actually understand how to utilize these programs in the context of what engineers do? And that's a lot of data display, data analysis, and discussion around data. So that's sort of where we try to focus our efforts for the programming. And you could also use it for doing something around simulations. And we're going to do that this year. I have a simulation for heat transfer in a bar. So they're going to build out a simulation in Python for heat transfer in a bar. And then we're going to run an experiment for heat transfer in a bar. And then they're going to compare their experimental data for the heat pulse to the theoretical data for the heat pulse. And so that should be interesting to see how well they do with that.